Welcome to another edition of Final Countdown. This is week 13, day 3. Week 13, day 3. Right. Starting with MCQs. Have a look. An ideal gas in a cylinder is expanded by moving the piston from very slowly. Very slowly means isothermal process. Isothermal process. Yeah. And then you have very quickly, very rapidly, adiabatic process. Adiabatic process. So isothermal process, delta U is going to be 0. Adiabatic process, delta Q is going to be 0, right? So represent the process, expanded, volume increases. So work output. So work output is positive. Delta Q equals delta U plus delta W. This is for a isothermal process. Delta U is 0, delta W is positive. Therefore, delta Q is also going to be positive. What can you say about delta theta? Delta theta is going to be 0, isothermal process. So looking at this, what can you say? Delta theta 0, delta Q is positive, 0. So this looks okay. This looks okay. This is wrong. This looks okay. This is wrong. Next is adiabatic process. Delta Q equal delta U plus delta W. Delta Q is 0. From this you can say delta U equals minus delta W. Okay. Work output is positive. No? So delta U is negative. Therefore delta T is also negative. Huh? Right. So delta T is negative. Delta Q is 0. Delta U is negative. This looks like correct. Here negative, 0, negative, negative. This is wrong. So this is wrong. This is anyway wrong. Work output positive, delta U negative. This is wrong. Delta theta negative, delta Q is 0, delta U is negative. Work done is negative. No, work done is positive. Only correct statement is answer number 1. Only correct statement is answer number 1. Okay. Right. Moving on. A person wearing a spectacle claims that he experiences a film of moisture formed on his glass. Now this happens in an earlier MCQ also. This was there. When you travel from a cold place to a hot place. Cold place to a hot place, right? Colder place, the glass is at a lower temperature. When you go out, the moisture around the glass will what? Suddenly cool. Cooling means condensation takes place. So cold to hot place only this happens. Cold to hot place when you travel. Huh? Right. So get down from an air conditioned vehicle. Air condition is cold coming out. So this is possible. Gets into a closed vehicle parked under the sun for a long time. So if there is a vehicle parked for a long time, inside temperature is high. You have experienced this personally. So you are going from a lower temperature to a higher temperature. Possible. Moves into a heated building in Norelia on a cold night. Outside cold, inside hot. A, B, C, all are possible. All are possible. Answer number 5. Right. Question number 3. Question number 3. A quality of a dry cell can be evaluated by studying the variation of voltage and internal resistance with time while drawing a constant current from a cell for a long period of time. The following graphs represents the voltage V and T, R and T possible curves. Out of the possible curves, which represents the best cell? Best cell means what? Time increases, internal resistance reduces, when time increases, reduction in internal resistance. It's a case, ideal cell. Okay. Now, if you are talking about ideal cells, well, that's the case. Right? So, rate of reduction should reduce. Rate of increase must reduce. Must be less. So you can't say entire radius will completely reduce. With heat it will increase, but the rate of increase should be less. And what else? The rate of reduction of terminal voltage or EMF. EMF should reduce. Rate must be less. Rate must be less. So these are highly impossible. These will never take place. These will never take place. So rate of reduction is less, means that is good. This is good. C and Q is good. Answer is answer number 2. Answer is answer number 2. So a good cell means rate of increase of inter resistance should be less and rate in which discharge occurs should be less. Okay, no? Right. Moving on. As shown in the figure, a person is standing on a shore of a lake. He spots a fish some distance below. If he uses a laser to locate the fish, he should aim the laser at, he should aim the laser at the fish. Now, the reason is, why can he see light rays coming from the fish? Denser air goes away to his eye. So he will actually see the fish somewhere here. Image of the fish is there. So if he points it to the image of the fish, light will go back again to the fish. There. So the image is formed somewhere here. Light rays go out as well. No? Image is formed somewhere here. Image. So if he points it to the image, light is reversible. It will go towards the fish. So directly on the apparent position of the fish. Directly on the apparent position of the fish. Okay, no? Right. Moving on. Right. MCQ 5. MCQ 5. So here they are talking about a metal wire. Metal wire with a insulation cover. Radius of the wire is D, thickness, radius is A, thickness is D. Now along the wire only heat is lost. Everywhere along the wire, along the circular surface area. So let's take the average circular surface area. Average circular surface area. So average is 2 pi A into L. 2 pi A plus D into L divided by 2. Common terms 2 pi L A plus D divided by 2. Simplify it. 2 pi L, 2A divided by 2 is A, D over 2. Average area. Average area. Okay. Now represent it carefully. Heat loss can be shown. Heat loss can be shown. Or heat transfer K times A delta theta over L. Q dot is I squared resistance per length into length. K times average area 2 pi L A plus D over 2. Delta theta and the distance covered there is D. L cancel off. I squared R D. K times 2 pi A plus D over 2 is equal to delta theta. Right. So we have got this. For all D, you can't get this basic relationship, no? I squared RD So average length so here your answers are possible k times 2 pi a plus d, k times 2 pi a plus d over 2 I squared rd, either this or this. For now remember you can apply this relationship if d is very small compared to a. So if d is large compared to a, the equations will change, it becomes non-uniform. So most probable answer is answer number 1. Most probable answer is answer number 1. Okay, right. So here don't forget it. This is valid, very simple. When the thickness here is very small compared to the radius. Thickness is very small compared to the radius. Right, moving on. Now this has been removed from your syllabus, but just remember it like this. Non-conducting sphere is same as the gravitational field strength inside the Earth's surface. It's a linear variation. A non-conducting sphere of radius r has a uniform positive charge distributed within the sphere. The electric potential with radial distance r is best represented by, if I show this theory, volume charge density q divided by 4 over 3 pi capital R cube. There. So I need to find the variation of electric field strength. Let's get the electric field strength variation. So simple R distance. So what is the charge? Same volume charge density q dash 4 over 3 pi simple R cube. So rho values are same. Rho values means volume charge density. So volume charge densities are same. Volume charge density. So the volume charge density values are equal. So now what I'm going to do? Now carefully substitute here. So if you simplify it, q divided by 4 over 3 pi capital R cube, q dash 4 over 3 pi simple R cube. Q dash is simple R cube, capital cube over capital R cube. Right, now let's work. Gauss theorem. E times A, sum of charges over epsilon naught. Gaussian surface area 4 pi simple R squared. Q capital R cube epsilon naught. E is equal to q divided by 4 pi epsilon naught capital R cube simple r. Variation inside is of the form y is equal to mx. Electric field strength variation. Na? Also you know electric field strength is negative potential gradient. Negative potential gradient. So here if it's of the form y is equal to mx, I'll just say mx. Mx form, mx dr is dv or mx dx dx. So if you do the integration, this beyond your scope, x squared over 2 plus c, it's going to be a maximum curve, maxima. So none of these give you maxima, only this gives you maxima. Only that gives you maxima. Also outside variation V proportional to 1 over R. So 1 over R variation is there. So only possible answer is answer number 4. But remember this has been removed from your syllabus. Huh? This has been removed from your syllabus. Okay. So this part, even though now here I have shown you some additional work. So once you know the charge inside using Gauss theorem, electric field strength variation is known, so using this you can actually find the potential. So minus x squared means maximum graph. Maxima graph inside is there only in answer number 4. But this has been removed from your syllabus. Okay, right. Input output characteristic of 3 ideal transformers are given. 3 ideal transformers are given. Right. Vp given, Vs given, right. So PQR. Transformer P can deliver large current than Q. So R or P. P input voltage is low, output step up. It's a step up transform. Step up transform means Ns is larger than Np. So if I say Vi is constant, so larger voltage means current is less. Q step up, but the ratio is smaller, no? Lesser voltage, larger current. Statement A is wrong. Statement A is wrong. So we have no problem there. Statement A is wrong. So whatever with A is wrong. Statement B. Transformer type P is suitable to construct a low voltage DC power supply. The step up transformer. Low voltage DC power, step up transformers you can't use. B is wrong. Whatever with B is also wrong. Only true answer is C. Transformer type R. Step down transformer. Step down. That means NP is larger than NS. Here NS over NP is less than 1, correct. Answer number 3 is correct. Answer number 3 is correct. Question number 8. The figure shows a positive point-like charge moving along a straight path between two fixed equal negative point charges. Two fixed equal negative point charges. Right. The variation of the force on the positive charge. So negative charge here, negative charge here, negative, negative, positive. Right. The closer I come, the greater the force. And the moment I am here, resultant force is 0. I mean, largest force but resultant 0. Then comes back here, but because there is a velocity, same velocity, it has a velocity here. It can't stop. So acceleration, here acceleration 0, velocity will take it there, so deceleration. Somewhere here it will come to what? Rest. Somewhere here it will come to rest. So what can you say? Maximum force occurs at the center, x equals 0. Maximum force acts at the center. Resultant force is 0. Resultant force here is 0. This is possibility, this is wrong. This is a possibility, this is a possibility, this is wrong. Right. Now, as it comes closer, force is inversely proportional to r squared. Force will increase, but not linearly, so this is wrong. Inverse. Clear? Inverse. Right. Once it passes, deceleration come into rest. These are also wrong. So out of this, the most suitable answer is answer number 2. Answer number 2. So here we can easily see the basic variation. Here we can easily see the basic variation. Right. Question number 9. Question number 9. This is a famous relationship actually. Famous relationship. Here we can say, when this loop is rotating inside, field is increasing at the opposite. So current travels in the anti-clockwise direction. And when the loop is coming out, current will travel in the clockwise direction. Induced EMF is BR squared omega divided by 2. Whether a rod rotates in a magnetic field or a disc rotates in a magnetic field or a loop rotates in a magnetic field, induced EMF is same. So your most suitable answer is answer number 1. So constant omega, radius is same. One moment it's going to be anti-clockwise, the other moment it's going to be what? Clockwise. Correct answer is answer number 1. MCQ number 10. two identical wedges, each of mass m, are placed to each other. So here the weight is there, you can mark it. Here there is a normal reaction R1, equal opposite normal reaction there. Weight is simple mg. Here also weight is simple mg. Symmetrical, no? Around this symmetrical. So here also R1 equal here R1. Right. Now here you can have R1 cos 45 in that direction. So there is going to be friction here. Here there is a different normal reaction. So identically looking symmetrical goes that way, friction this way. Right. Largest M that can be without move on the verge of moving. On the verge of moving. On the verge of moving. So let's work this problem out carefully. Here 45, here 45, here 45. You have R1 cos 45, R1 cos 45, R1 sin 45, R1 sin 45. Every action has an equal opposite reaction. Here you have R1 cos 45. I will erase this because now right now I have shown already, yeah? They don't erase it. R1 sin 45. On one side I will mark. So sum of forces in the upward direction balances sum of forces on the downward direction on capital M. 2R1 sin 45 equals capital Mg. R1 sin 45 is capital Mg divided by 2. Don't forget now, R1 sin 45 is same as R1 sin 45 is 1 over root 2, cos 45 is also 1 over root 2. So here you have a basic relationship, right? No problem. No problem there. Who is pushing it here? Let's take the wedge now. Sum of forces acting upward balances sum of force is acting downwards on the wedge. Upward is R dash, downwards is simple Mg plus R1 sin 45. So R1 sin 45 is capital Mg over 2. Okay. Capital Mg over 2. 2 simple M plus capital Mg divided by 2. Right. On the verge of moving, sum of forces to the right balances sum of forces to the left. R1 cos 45. Left is friction mu times normal reaction R dash. R1 cos 45 is capital Mg over 2. R dash is 2m plus capital M over 2g. G 2 cancel off, open brackets. M equals 2 times mu simple M, mu times capital M. They are asking the largest possible value for M. M minus mu capital M, 2 mu M. M is common, 1 minus mu, 2 mu M. Capital M is 2 mu simple M, 1 minus mu. So working the problem backwards, you can obtain the basic relationship. 2 mu M, 1 minus mu. Answer is answer number 3. Answer is answer number 3. Right. Moving on. Structured essay. Electricity structured essay. Carefully look. Now, a student is asked to find the value of Rx. of an unknown resistor connected to the circuit shown. Using a graphical method, R is a variable resistance provided by a resistance box. L is reading of the voltmeter. V is the reading of the voltmeter. V is the reading of the voltmeter. The internal resistance of the voltmeter is large. 2 new dry cells, each of voltage 1.5, is used to provide a voltage V0 of 3 volts. Assume the internal resistance is negligible. Right. Indicate the polarity of the voltmeter used. So polarity means positive connected to positive, negative connected to negative. These are very basic work. Right. Next one. In order to plot the graph, the student is asked to take several voltmeter readings by varying resistor R. Write down expression for V in terms of R, V0 and Rx. Right. So voltmeter V, that is R times V0 divided by R plus Rx. R times V0 R plus X. Voltmeter V. Okay. Potential divider relationship. Right. Rearrange the variables to plot a straight line graph with 1 over V as the axis. So V is equal to V0 times R, R plus Rx. 1 over V on the y axis, R plus Rx divided by V0 R. 1 over V. 1 over V is equal to, simplify the relationship, R divided by V0 R, Rx divided by V0 R. Simplify the relationship there. Rx over V0, 1 over R, 1 over V0. Graph is of the form, your variable resistance is R, no? Yeah, variable resistance is R. So here graph is of the form y is equal to mx plus c. Y is equal to mx plus c. Okay. Right. Y equal mx plus c. What's the next relationship? Draw a rough sketch of the graph. Rough sketch of the graph means 1 over V per volt, 1 over R per ohm, y equal mx plus c graph. Y equal mx plus c graph. Okay. Y equal mx plus c graph. Right. Then what? Then what are they asking you? Basic relationship. Don't forget to name the 0, 0 axis here, very important. Next one. How would you find the value of Rx from the graph? How do you find the value of Rx from the graph? Using the gradient of the graph and the y-intercept. Gradient divided by y-intercept. Gradient divided by y-intercept. That will give you Rx value. That will give you Rx value. So gradient divided by y-intercept. How would you find the voltage V0 of the battery using the graph? Voltage V0 is y-intercept. Y-intercept is equal to 1 over V0. So V0 is equal to 1 divided by y-intercept. Y-intercept. Part C. You are given that the internal resistance of the voltmeter is 1500 ohm and the value of Rx is in the order of 100 ohm. Of the following ranges given, pick the range of value you would choose for R in order to obtain a straight line graph. So you must make sure no current passes through what? The external resistor. Now, if current starts going through the voltmeter as well, we have a problem. So if you choose a value, Rx value, if you choose a R value between here, current will go through the voltmeter as well as what? R. So make sure that R value is very small. R value is very small means this one. So the reason there you can write. What's the reason? What's the reason? No current should pass through the voltmeter. Therefore, the resistance R should be much more smaller than the voltmeter. Right? How would you check the experiment whether the data have been affected by the possible rundown of the battery? What do you mean by rundown? Voltage EMF reducer. So what do? Maybe you can repeat and take the readings. Okay. Repeat and take the readings is one effect. Okay. You can repeat and take the readings and check if you get the same voltage values. Right there. Repeat the readings taken in the beginning back again. Repeat the readings taken in the beginning back again. So you can see whether the EMF has reduced. Right. If you have discovered that the battery has run down, how would another battery which lasts longer using a new 1.5 volt cell to give before repeating the experiment? So how will you connect this? If you have discovered that the battery has run down, how would you design another battery which lasts longer time using a new 1.5 cells to give 3 volt before repeating the experiment? So you all know this, no? Connect the batteries. Now they are connected to. Connect the batteries like this: 1.5 volt, 1.5 volt. Here 1.5 volt, 1.5 volt. Battery pack. When one is discharging, the other will keep giving the same voltage. Right there. We can make a battery pack by connecting the cells as shown in the figure. By connecting the cells as shown in the figure. Right. So parallelly connect means same EMF is given at the end. Huh? Right. Okay. Electricity essay question. Electricity essay question. Right. Okay. The circuit shown in the figure has 3 inputs. Input A, B, C. A, B, C. VA, VB, VC of either 0 or 7 volts can be applied between the inputs X and Y. Across the inputs X and Y. Here. So you can put the inputs across X and Y. If a 0 voltage is applied to all 3 inputs by grounding each input terminal as shown in figure 2, find. Now here find Roman 1 equivalent resistance across ZX. Okay, 0 volt here, 0 volt here, 0 volt here. Think carefully. These also grounded. But are they asking you voltage across Z and Y? Z and Y. All are connected to Y. So one end is connected to 0, other end is connected to Z. Okay, no? One end is connected here 0 volt, no? 0 volt, 0 volt. Okay. So one end is connected to Z. I'll draw like this. One end is connected to Z. One end is connected to Z. So this is connected to Z. R0. R0 divided by 2. R0 divided by 4. Right. One connected to Z. And the other end is connected to what? Y. B voltage 0. So all they are connected together. So this potential same. So here grounded. Equivalent resistance all are parallel to each other. 1 over R0, 1 over R0 over 2, 1 over R0 over 4, 1 over R0 over 4. Simplify this. 1 over R0, 2 over R0, 4 over R0. From this we can build a common relationship. 7 over R0. Effective resistance. So effective resistance is R0 divided by 7. R0 divided by 7. What's the output voltage? Don't forget output voltage is taken between Z and Y. Z and Y. Clear? Z is there. Y is anyway grounded. Potential 0. Potential 0. Z is a open terminal. D is open terminal. Currents can't go. So only voltage can exist. Only voltage can exist. Output voltage is going to be 0 volts. Output voltage is going to be 0 volts. Right. Now copy the given table below. Now 007 here 0 volts. Already found. Now they are telling you for this situation fine. Right. What can you say? These two are parallel to each other. If I take A separately, R0 is there. That is connected to Z. This is connected to R0 over 4, R0 over 2. R0 over 4, R0 over 2. The other end is connected to Y. Other end is connected to Y. Y is grounded. What can you say about the potential here? This potential here is 0. What can you say about the potential here? This potential is 7. What are they asking you? The potential between Y and Z. Output voltage is here between Y and Z. Between Y and Z. Clear? So between Y and Z only the voltage is there. So here R0 over 4, R0 over 2. If I simplify that carefully. Now these are calculation which we can go in do in the board. So let's go move forward. We'll solve this line here. Parallel here. Parallel connection there. So we can take 4 over R0, 2 over R0, 6 over R0, R0 over 6. R0 over 6. Between Y and Z. Total voltage is 7. So potential divider method, I'll solve it here. Voltage between Y and Z. R0 over 6 multiplied by 7 divided by the addition. Divide by the addition. R0 over 6 plus R0. R0 over 6 times 7. 7 R0 over 6. R0, 6 cancel off. 1 volt you will get. So correct answer here is 1 volt. Correct answer here is 1 volt. So what we'll do is we'll draw this circuit separately. Then we can fill the rest and go nicely. Right? We'll fill the rest and go nicely. Carefully look. So here R0 over 2. Here R0. R0 over 2. R0 over 4. Here XY. Here you go. This is grounded. This is your Z, this is your V0. Here they are given A, B, C. A, B, C. Look at this carefully. Well, superb question. Huh? Superb question. Now what have we done? We are done for the first part. Now next is B is going to be 7 volt. Then A and B is going to be 7 volt. Right. B is going to be 7 volt. Huh? Okay. B is going to be 7 volt. Here 0 volt. Here 0 volt. Look at the board carefully. Here you can simplify. R0 divided by 2 connected to Z. 7 volt here B. A and C is grounded. That is your Y. That means R0 over 4 and R0 here connected to Y, which is grounded. Y is grounded. They are asking the voltage between Y and Z. You can simplify this R0. Here parallel 4 over R0, 5 R0 over 5. R0 over 2. 7 voltage. Z. Y. Voltage here. V, Y, Z. R0 divided by 5 multiplied by total voltage divided by the addition. R0 divided by 2 plus R0 divided by 5. So here 5 to 7. V, Y, Z. R0 divided by 5 times 7. 7 R0 divided by 10. R0, R0 2, 7 goes on top. 5 times 1, 5 times 2. 2 volts. So fill the table there with 2 volts. Right? Fill the table there with 2 volts. So here we can fill with 2 volts. Next one. B and A are 7 volts. B and A are 7 volts. B and A are 7 volts. Right. If B and A are 7 volts, both can be connected together there. R0 divided by 2. R0. R0. This is connected to Z. Then R0 divided by 4. C is connected to Y, which is grounded. Simplify here parallel. 2, 3. R0 divided by 3. R0 divided by 4. Here Z. Here Y. Here 7 volts. Now what is the voltage here? Voltage between Y and Z. R0 over 4 times total voltage divided by R0 over 3 plus R0 over 4. R0 over 4 times 7. 7 R0 divided by 12. 7 R0. 12 divided by 4, 3 volts. So here you go 3 volts. Then C is 7. A and B are 0. C is 7. A and B are 0. They will give you marks for all of this. Huh? C is 7. So R0 divided by 4, 7 volt there. That is connected to Z. Then the other two are parallel to each other, grounded. R0 divided by 2, R0. Here Y. Here R0 divided by 4. Parallel to each other. Multiply both the resistors, divide by the addition. So 2 over R0, R0, how much? R0 over 3 now. R0 over 3. Here 7 volt, here Y. Voltage between Y and Z. R0 over 3 times 7 volt divided by the addition. R0 over 4 plus R0 over 3. R0 over 3 times 7 divided by 7 R0 divided by 12. 7 R0 divided by 12. 7 R0 is 12 divided by 3, that is going to be 4 volts. That is going to be 4 volts. Now here you can come and write 4 volts. 4 volts. 3 more rows. A and C are 7 volts. A and C are 7 volts. So if I draw this, A and C are 7 volts. A R0, C R0 over 4, 7 volt there. That is connected to Z. From there it's connected to R0 over 2B, grounded. Simplify it. Effective resistance here R0 divided by 2, parallel. R0 divided by 5, 7 volts. Voltage YZ. R0 divided by 2 times 7 divided by the addition. R0 over 5 over R0 over 2. Simplify this. 7 R0 divided by 2. 7 R0 divided by 10. 10 divided by 2 is going to be 5 volts. 10 divided by 2 is going to be 5 volts. So here 5 volts. Here 5 volts. Next is C and B 7. C and B 7. C and B is 7. C and B 7 volts. That means C and B both ends, they are parallel to each other. C and B 7 volts means you can join them together. R0 divided by 2, R0 divided by 4. What is the end of C and B? C and B ending at Z. What is remaining? A. A is 0. A 0 means A is like grounded. So here R naught, grounded. A is here grounded, 0. The other part of A is connected to Z. That's also done. C is Y. Simplify here. Effective resistance. R naught here grounded. Parallel R naught over 6. 7 volts. Z Y. Voltage between Y and Z. R naught times 7 divided by R naught plus R naught over 6. R naught 7. 7 R naught over 6. 7 R naught cancel off, 6 volts. 6 volts. Then directly we can go to the last one. Last one is what? ABC all are 7 volts. ABC all are 7 volts means here 7 volt. R naught over 4. R naught over 2. The other is R naught. Other end is connected to Z. Other end is connected to Z. Here you have Y is grounded. Clear? Okay, no? So your base relationship is given there, no? Base relationship. Okay. Base relationship is given. This is the last one, na? ABC all are 0. Sorry. ABC all are 7. ABC all are 7. Right. Okay. Now what? Here if you simplify this, 7 volt there. 7 volt there. Here you have R naught divided by 7. R naught divided by 7. Look at the basic relationship. So 7, 7, 7. All are 7 means nothing is grounded. So between grounded and Z point. Right, no? Okay. So total voltage representing here is directly 7 volts. So if I are taking between Y and Z, Y is anyway grounded, no? What's the voltage at Z? Here. Voltage between Y and Z. Okay. Okay, no? So here 6 volt already done. 6 volt already done. Then they are connecting ABC all are 7. ABC all are 7. ABC all are 7. If ABC all are 7, Z voltage is there, right? ABC all connected here, 7 volts. here Z. Y is grounded. Y is grounded. Is there any way to connect Y and Z again? No. So what will be the potential difference? Circuit can't continue, so 7 volt here means 7 volt here. Potential difference between these two is going to be YZ is going to be 7 volts. So from here we can say these are also 7 volts. Right. So I think we have done all of this. Row 3, row 5 and 6. And put the values. Right. Roman 2. If 7 volt and 0 volt represent 1 and 0, explain the function of the above circuit. So I'll draw the circuit back again. Here A, B, C. Output voltage 0, 0, 0. 0, 1, 0. 1, 1, 0. 0, 0, 1. 1, 0, 1. 1, 1, 0. 1, 1, 1. Okay. 1, 1, 1. So technically the outputs are 0, 1, 2, 3, 4, 5, 6, 7. So what has happened? If I take 1, yeah, converting base 10 values to base 2. Converting base 10 values to base 2. Right. Okay. So there you go. Electricity question completely done. Electricity question completely done. Right. Next one, essay. A closed transparent chamber of volume 1 cubic meter contains air at 30 degrees. Contains air at 30 degrees. Relative humidity 80%. Air inside the chamber is first dried by means of equipment which removes moisture without changing its temperature, so that the absolute humidity is dropped to 50%. Absolute humidity is dropped to 50%. So here mass of water vapor was m Vins, now here m over 2. Same temperature, water vapor has been removed. Absolute humidity for air saturated with water vapor is 30 grams per cubic meter. 30 grams per cubic meter. Right. So if I do the calculation here, so what are they asking you? Calculate the absolute humidity of dried air. Calculate the absolute humidity of dried air. So let's find the value here. Relative humidity is absolute humidity divided by absolute humidity at saturation multiplied by 100. Now here 80%, absolute humidity at saturation is 30 into 100. Absolute humidity is going to be 80% multiplied by 30, 24 grams per cubic meter. Now dried air 50% has been removed. 50% of this M has been removed. So absolute humidity of dried air is 24 50%, 12 grams per cubic meter. 12 grams per cubic meter. Okay? 12 grams per cubic meter. Right, moving on. The dehumidifier is then removed and the chamber with dried air is used to study the drying of paddy. For this 750 grams of wet paddy is introduced into the chamber. Now inside your chamber how much you have? 30 degrees Celsius, 12 grams per cubic meter of water vapor is there. 750 grams of wet paddy is introduced. Initial moisture content of the paddy sample amounts 20% of the initial mass. So 750 grams, 20% is 0.2% is the moisture. So 0, 0, 1, 14, 15, 1 decimal place. 150 grams. 150 grams. Paddy sample is kept on the pan for electronic balance placed inside the chamber and its mass can be read from outside. So you have 12 grams of water vapor separately. 150 grams of water vapor is also there. Water vapor from paddy. Water vapor from paddy. This is water vapor in room. Water vapor in room. Right. What's the saturated vapor here? Saturated vapor is going to be 30. Yeah? Up to 30 it can increase. Right. Find the mass of moisture present in the given paddy sample before placing it in the chamber. So 750 grams into 0.2%, that's going to be 150 grams. Right. As the paddy dries, the variation of its mass m with time is displayed below. Give reasons for the shape of the curve. Here. What's the shape? The moisture is absorbed to the room until saturation is reached. Saturation is reached. Why the mass attains an equilibrium value at mass ME after a certain time? That means that saturation, maximum mass of water vapor that can be there is 30 grams per cubic meter. So saturation has reached. Saturation has reached. So another 18 grams can be added. 18 grams can be added until saturation. What is the relative humidity of air inside the chamber when it reaches this value? 100%. Saturation reached. Calculate the equilibrium mass of ME. Look at the board. These are scale mass. Huh? So 30 degrees Celsius, RH is 100%. Or 12 grams plus another 18 only saturation will reach. 12 grams plus 18. Look at the board. Huh? 12 grams plus 80. So from 750, 150, 150, from 150 grams, 18 goes, 132 grams left, plus water form left, plus 750 into 0.8, 600 gram here. Altogether 732 gram weight is there. So weight there is 732 grams. 732 grams. ME. 18 grams are added saturation remaining from the 150, 132. 132 plus 600 grams of actual weight, 732. Calculate the remaining moisture content in grams of the paddy sample when its mass becomes ME. Remaining moisture is 132 grams. Already calculated. 132 grams. If the percentage moisture content of the paddy sample is to be reduced to 10% of what should be the minimum value, if percentage moisture content of the paddy sample is to be reduced to 10%, what should be the minimum volume of the chamber so that it can be employed with dry air prepared in the same manner as given in the beginning of the question? Oh, wait, careful. If the percentage moisture content of the paddy sample, so think, paddy sample moisture 150 grams. Only 10% of moisture can be there. Remaining or required final moisture. Required final moisture. Required final moisture is 10% of this, 15 grams. Only 15 grams should be there, 135 should go. Minimum value of the chamber that should be there. Minimum value of the chamber that should be there. Right now the chamber, go back to basics. 30 degrees Celsius. 30 degrees Celsius. Volume we don't know. Relative humidity beginning how much? 80%. Relative humidity 80%. RH 80%. Clear? So required final moisture is 15 means 135. 135 should be added to the atmosphere. 135 should be added to the atmosphere. Plus already there is a remaining of what? Already remaining 12, no? Already remaining 12. Clear? So 30 grams per cubic meter. Per cubic meter we are adding per cubic meter 18 grams was added. Earlier was 12 was there. 18 added. Yeah, 18 added. So actually we can only have 135. So 135 should be added. 135 should be added. 150 gram sample, 135 should be added. Here, 135 should be added. Think carefully. So initial volume is there. What do? We remove some water vapor, make it half. Half. When you make it half, you have how much? 12 grams of water vapor. So next chamber, 12 grams per cubic meter. For this only I am adding paddy. Out of that paddy, 150 gram moisture is there. Final only 15 grams should be there. 135 grams should be added. 135 should be added. 135 should be added. Wait. Now, anyway, saturation 30 grams per cubic meter. So already 12 grams are there. 135 I should add. 135 I should add. Here. So already 12 is there. Out of this, how much can be added? 18. Another 117 more. So 117 more means, if I have 4 cubic meter, right? No? 4 cubic meter means 120 cubic meters can be added. 120 grams can be added. Right? Already 12 grams is there. Already 12 grams is there. So here 750 grams of paddy sample, wet paddy, only 10% of moisture can be kept, means only 75 grams can be kept. 75 grams of moisture can be kept. That means initially there was 20% of this. So here moisture present in the paddy is 150. Now 10% of the weight only moisture can be there. So percentage moisture content of the paddy sample is to be reduced to 10%. So from 150 to 75 we must reduce the moisture content. Here 150 to, so initially there was 150 grams of moisture, 20%. Now we must reduce that moisture content to 10%. So 75 grams. So there is another 75 grams that should be evaporated. Now look at this. At 30 degrees Celsius, already 12 grams per cubic meter is there. We can add another 18 grams. So how many 18 gram sets are there? 18 times 4, slightly more, no? So 75 divided by 18. How many 18 gram sets? If you divide 75 by 18, you will get the basic relationship. 75 divided by 18, you solve it. 75 divided by 18, 4.16, or we can say 4.2 cubic meters. So what is happening is, earlier there was 20% moisture. Now out of this we want to make it to 75, 10%. 20% we have to make it 10% moisture. That means only 75 grams of moisture can be there. Earlier there was 150, no? From 150 we must now add another or reduce some more 75 grams. So normally 12 grams per cubic meter is there. 18 grams is added. So how many 18 gram sets are needed to absorb all the 75? 4.2 cubic meters. So around 4.2 cubic meters. Okay. The atmospheric air heated without using a dehumidifier can also be used for drying. If the closed chamber of 1 cubic meter is filled with air which was originally at 30 degrees and relative 80, now heated to 70% to perform this study, calculate. Now initially 30 degrees Celsius, RH is 80%. RH is 80% means 12 grams per cubic meter is there. Now I increase this temperature up to 70 degrees. Unsaturated, no? Here also unsaturated. Here also guaranteed unsaturated. the initial relative humidity of the heated air inside the chamber before introducing the paddy sample. So now absolute humidity at saturation 30 grams per cubic meter at 30 degrees Celsius. 30 grams per cubic meter at 30 degrees Celsius. Okay. Right. Now, right, I think they should give you some values, otherwise you can't solve this. Given. Absolute humidity at 70 degrees Celsius is given. Okay. Right, now we can actually solve this. So, what is happening? Atmosphere air is heated to a temperature, original 80%. Original value 80%. (24 grams per cubic meter), right? Original 24 grams per cubic meter. Okay. Original 24 grams per cubic meter. You can tell me. When it's unsaturated, mass will not change. Same mass. Relative humidity is absolute humidity at room temperature divided by absolute humidity at saturation multiplied by 100. So unsaturated here 24, 216 multiplied by 100. 216 multiplied by 100. Your answer will be 11%. 11% RH. 11% RH. Expected value for ME. Now you are doing the experiment from the beginning. 70 degrees Celsius. 24 grams per cubic meter there. Maximum 216 grams per cubic meter. 750 grams of paddy sample, out of which 20%, 150 grams of moisture is there. 150 grams of moisture is there. Grams of moisture is there. Okay, 150 grams of moisture is there, which means it will vaporize how much? How much can it vaporize? Ra 24 is there. So we have 216 minus 24. 192 grams per cubic meter can be added. Here, 192 grams per cubic meter can be added. So only 150 grams is there, no? Only 150 grams is there, no? So can these 150 grams be added? Yes. 150 grams can be added. 150 grams is added means now remaining mass is 600 grams. Why? 750 minus 150 is going to be 600. So here 174 grams per cubic meter. It has not reached saturation. Good. So here expected value ME is actually 600 grams. If you want, you can find the new relative humidity. New relative 174 divided by 216 into 100. 174 divided by 216 into 100 is 11%. again 80.6%. Right? So this concludes the discussion for week 13, day 3. Week 13, day 3. We have discussed the 2011 paper completely. Okay? Mechanics question, essay question done. All 4 structured essay done. All 50 MCQs done. Mechanics essay, waves essay, light essay, surface tension, gravitational fields, electricity, thermal. Catch you all again with another edition of Final Countdown.